what is the role of an architect, software architect, in the security of the products that we are building? First of all, we need to understand that every stakeholder of whomever is building that software are all responsible for the security of the software they are building. I would like to start with visualization of the data breaches that has happened since 2004. You can see it here. Since 2004, it was till 2009, it was quiet. But beyond that, if you look at it, till 22, there have been so many data breaches that has happened. So who is responsible, or how do we prevent all these things? And the data what we have right now is only up to September 2022. And this particular visualization, I've taken it from a website called Information is Beautiful. This is not a security related website, but these people are able to build great visualization based on the data, whatever they have. But as of now, till September 22, related to the security incidents that has happened so far are documented here. We always consider security as a layered approach, in which the first one is the perimeter security, where we talk about all the DMZ, firewall, and network access translation. And next is related to the network security, where we place VPN and intrusion detection systems. And then endpoint security, wherever the host that we are installing our softwares, they're all are on the right version, the latest version, and are patched to the appropriate level. This is what was considered as secure during the initial days. So when we talk about deploying a software in the production environment, most of the time companies have focused primarily on these aspects. But recently, though the authentication, authorization and all are there, application security was never considered as an important aspect, and how to protect the data. So this is also very important in the more connected world, where there are multiple systems that are connecting, and there are different people who are connecting to our systems and accessing the data. And when we talk about the software development lifecycle, the application security, we have in each and every SDLC phase, there are certain things we need to take care. So everybody who is participating in the software development will have some role to play. So from the product managers who are working on collecting the requirements, to the architects who would be responsible for designing, and the developers and testers who are responsible for the implementation part, and the deployment team who is responsible for deployment, and the team who is supporting. All of them are responsible for security, and for each and every one of them, there are certain tasks that they need to do. And this is a process that was outlined by Microsoft back in 2005-06, but this has been adopted by multiple companies now and are focusing on coming up with this particular process. Right? So I'll be focusing primarily on the design aspects for the architects. What do the architects need to do to contribute in the secure development lifecycle? First one, we need to understand what are the secure design principles. Next one, building the threat model. Third one is the building or designing the security controls and countermeasures. When it comes to secure design principles, we know we have a lot of principles with respect to development of normal software development as well, and we saw some of them during our previous sessions also. But in this particular this particular list actually contains only the principles that are specific to secure design. There are many governments and consortiums have come up with secure development principles, but most importantly, the most important thing to note here is everybody has some sort of overlap in whatever they have defined so far, right? So what I've done is there are many principles, 10, if you notice this 8 principles, 33 principles, 14 principles, there are so many principles that are available in the market now, but we are not going to focus on each and every principle. But if you look at it, the 10 are the most important principles that we need to focus on. If you have good understanding about these things, then you would be able to build a more secure software. The first one is related to the defense in depth, which is what I showed in my first slide, where we take a layered approach to defend the data that we are going to protect. Next is file secure. In this particular principle, even if there is a failure in the system, we have to ensure that it does not elevate the privilege that is given to a specific user to a different thing, or it should not give away any additional system design related details when it is sending out the error message. And least privilege, we always have to ensure that we give the most appropriate amount of privilege to any user, the authorization. We cannot give the admin access to a normal user. So those kind of things needs to be taken care. Separation of duties. There are scenarios where we may have to in a financial services or more the systems where we need more secure transactions are happening. We need to ensure whenever there is a setup being done, we may want to have multiple people involved in a workflow kind of structure where one person will set up and another person will approve it, review it. So those kind of things are need to be taken care in case of softwares where which are dealing with very sensitive data. Next is economy of mechanism. Most important thing, we have to keep our design as simple as possible so that it will be easy for us to manage it as well, right? Next is open design. This is where design should not be kept as secret. Everybody, all the stakeholders should know what is the exact design. We should not have anything hidden from the team. What is secret is only the data, the sensitive data. That is what needs to be kept as secret. For example, in the cryptographic algorithms, if you notice, everybody has access to what is that algorithm, how it works, all those things are available. But what is secret in that is the key, the actual encryption key that we are building. That is what is the secret. So this is how we have to consider this particular principle. Next is secure defaults. When we install a software from any third party, they may be having some secure default set of data like password and all these things. Those things need to be modified. Second one, we need to have proper password reset rules and all complexity rules need to be set up. Authentication, most important security aspect. Cryptography. We need to, this is again very important to have the guidelines on what kind of cryptographic keys and algorithms that are allowed within this within the infrastructure. For that we need to have proper guidelines that are being outlined by the security teams. So accordingly we'll have to set it up. Finally, complete mediation, where before, for example, if I'm requesting for a particular data from a system, the system must check whether I have the rights to execute that particular function. Then only it should allow me to execute. So first thing, validate whether this particular user has access to a particular feature. That is what is complete mediation is all about. I'm coming to the most important topic for an architect, that is threat modeling, right? So in threat modeling, first thing what we are going to do is first we need to understand the different concepts that are part of the threat modeling. These are the assets. Every organization will have asset. What is an asset? Let's take an example of our house, right? Within our house, we have walls, we have windows, we have doors. And inside that, these doors are there for securing our house. And we have a lot of items within the house. We have our furnitures, we have our TV, electronic items, and we also may have a safety locker at home, right? What do we keep in the safety locker? We will not keep our mobile phones or everything is valuable. Whatever is there within the house are all valuable. We are trying to protect it using different things like doors and walls and all these things. But only the very most valuable things are the ones we keep inside the security locker. What I'm trying to say here is, everything within an infrastructure is an asset, but each asset will have different value and how it has to be protected. So organizations always want to protect their assets. When I say assets, it is right from data of the customer or their own employee information. Anything that is valuable to the customer or organization is a asset. Then comes every company will also have security policies to protect their own data. So these policies are very, very important to be defined upfront. And there can be risks for assets. For an organization always wants to reduce the risk to their data, and to reduce along with the risk, there will be vulnerabilities in the system, whatever we are building. Our objective will be to reduce the vulnerabilities and the risk. So organizations will use the security policies to regulate the countermeasures, and then the organization establish the countermeasure and use them to reduce the vulnerability and the risk. So these are the things that we will be doing as an engineering team or as a software group. But from whom are we protecting from? From the threat agent. A threat agent can be anyone who wants to abuse or damage the asset. So it can be an hacker, it can be an unhappy internal employee, or probably an employee who, without any intention, they may, for example, an operation engineer may log into a Linux system and doing some deployment. During that time, by mistake, they may execute some command which will erase the entire data. Even that is also possible, right? So we need to ensure, so they are also considered as threat agents in this particular scenario. And next one, even we are in a much more connected world, and even when customers are using their systems to connect to our applications, and by mistake, if they are using their test environment to connect to our production environment, and probably they may be running some load tests, they may also lead to some sort of damage to to our assets. So what do? They may use, they are actually the threat to our assets, and they will increase risk to our assets, and they may exploit the vulnerabilities that are there in our system to damage our assets, right? So these are the primary concepts related to threat modeling. What we do is, I'll just to go through the 4 different stages of threat modeling, and we'll see how we can define or develop a threat model for the application that we are building. First step would be to, as an architect, software product architects, our responsibility would be to diagram the application architecture. It can be an application architecture, can be physical architecture, it can be any architecture diagram that you are comfortable with, as long as it captures all the elements of the particular system, and that gives us a good idea about what we need to protect, right? So that is what we do with an application architecture diagram. Then we'll have to identify what are all the different threats that are possible. What are the different data flows, whether the data flow is secured or not, and what are the entry and exit points of each and every component. And we also have some references that are available as part of OWASP Top 10, SANS Top 25, and Stride is a threat modeling framework. We can find out, we can find different lists. Based on that, we should be able to identify the potential threats that may be possible for our application. Next one, we'll have to now prioritize the different threats and which one to be addressed first. So we have to prioritize them and then start identifying what are all the controls that we can set in those for those threats. Finally, we'll have to document everything in such a way that those controls or whatever countermeasures that we are recommending should be given to the development team, and they should be able to start working on those kind of the countermeasures, right? And there are many models that are there for implementing threat modeling. The most popular one is the STRIDE model, which is developed by Microsoft again. And this is what the STRIDE is an abbreviation of spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. And each of these threat is related to your property and what it can do. So this if we understand this, then when during our modeling exercise, we will be using these threats and the properties and then position them in our diagram so that we will be able to understand things much better, right? So I'm taking a simple example. Usually for threat modeling, we use Microsoft's threat model that's one of the most popular threat modeling tool. But for simplicity purpose, it will not look very beautiful to show it here. But that's why I'm using a different tool just to show what are all the different things that we can identify and how we are going to do it. But please try it. You can also check the other open source tools that are available. But Microsoft's tool, I'm more comfortable with Microsoft's SDL tool, right? And with the application, this is a sample application architecture. It does not do anything fancy. It has database, it has an identity store, it has APIs, UI. What does it do? It doesn't matter, because we are only concerned about these things as of now, right? In this diagram, we captured some of the components, capture the boundaries, whether it is internal or internet based or a restricted internal network, and what are all the different protocols that it uses to communicate with each and other components. So if we capture these things, this will help us identify what are the different assets we have, and what are the threats that can be possible, and how we can protect it, right? So first one, we have HTTP, the entire site is protected using HTTPS TLS certificate. So the certificates, the server certificate is the first asset. We cannot, because that is given to our organization or given to the customer's organization, that needs to be protected. It should not be kept loose. In some of the system, people may keep it in the file system itself, but that is one of the. But it is a very important asset to be protected. Second one, the customer's profile, the user data, email address, their name, company address, all these kind of things. Third one, the credentials that we use to connect to different external systems, including database. Next one, the session details, when user logged in, the session details. And there could be some of the application may have some of the data as a member-only content, and other for the APIs, all the resources needs to be protected, and the application data also. Within the application also we need to protect a lot of data. And these are the different, there may be many, but in this example I have taken only few of the assets that can be considered for our example. Next is threat agents. Who are all the different people who can be a threat? External TA01 is identified as an external customer based in their system. As I said earlier, I gave an example of a testing environment system is connected to a production environment system. So that may cause a problem for us. Second one is an external real hacker. So those kind of people. And the TA4 is an app which may be running from some external system, like bots. We discussed a lot about bots in our previous session. Bots also can be a potential threat to our assets. And internal users, either an unhappy user or a person who did a mistake. By mistake, they deleted something. So those kind of things. So these are the 4 different threat agents that we have identified in our app. And now we have to see what are all the different controls we have in our system. So each and every communication is happening through TLS, so we are good with that. And Next one is we have authentication policy, that is 02, and 03 is LDAP credentials. Where are we storing? So all those things are listed here. What are the different controls, and where we have it in the system. So that is what is documented as part of the controls, right? Next is what we are doing. We are going to create a traceability matrix. So in this matrix, we will identify what are the different threats that are possible based on the threat model what we develop. So we are going to use threat agent as an external hacker can try to get the customer's credentials by using the brute force method, and the attack surface is something, how will they be able to do it? Using a browser, and then what is their goal? Get user credentials, and what would be the impact, and how do we control it? So this is how we document each and every threat, and this document, it may not be possible for the one single person and one single architect to identify everything and then document it. It will be a team effort, and we have to include the senior members or other developers also into the system, into the discussion, and then work on this threat modeling exercise and prepare this matrix, and then we have to give it to the engineering team so that they would be able to work on that, right? So next responsibility of the architect is to provide information or guidance about the security controls and the countermeasures. In this, there are two different types of controls and countermeasures can be given. One is a technical one, and second one is related to the procedural part, right? And in the technical countermeasures, we can recommend different type of access controls like authentication, authorization. What type of authentication is allowed? Do we need MFA? Do we need self-sovereign identity? Do we need to support federated? Do we need to support social login? All those things will be provided in this particular part of documentation. Next is intrusion detection and prevention. These we have third-party softwares. Even OpenText has their own software for intrusion detection. So we can use this in the perimeter and other surfaces. With respect to encryption, architects will have to ensure that we use the right algorithm, recommend the right algorithm, set of algorithms, recommend the right key lengths. So those are some of the responsibilities of an application architect, application security architect. So we need to provide those details, and we need to ensure that that is being followed in the production environments. And vulnerability scanning, OpenText has acquired Micro Focus recently, and as part of that, we have gotten the Fortify SaaS tool also. It's part of our company now. We are using this Fortify for quite some time, more than 10 years, and we are very happy that it's now part of our own company. So these tools, automated tools, will help us scan our software in the development cycle itself, and will help us identify the potential security problems and address them. So that is one more technical countermeasure that we can recommend to our engineering teams. And the next one is related to the procedural countermeasures. Most important thing, every stakeholder must be given or must be recommended to take the security awareness training, so that everybody knows what needs to do and why we are trying to do. And again, incident, if there is some hack or if there is any information loss, how do we need to respond? First, how do we contain that particular incident, and then ensure that there is no more leaks, and then how do we take it to the customer, and how are we going to address to the public on what we have lost? In the first slide, I showed an infographic that had more than 30,000 records that have been lost, but if you notice, there have been more than billion records that are being lost. So those kind of, we don't want to get into that kind of mode. So we need to ensure that we have a proper plan on what needs to be done and how we can contain them, right? And change management, and we have to have a proper procedure on how the changes are requested, how they are documented, and how they are implemented and deployed in the production environment. And always ensure we need to have a least privilege set in our systems. So making secure design, secure software is a responsibility of everybody who is involved in the development of building the software. And secure design principles will definitely help us reduce the number of security incidents that can happen or any breaches that can happen within our system. So that is very important. So not many people are adapting to this application security practice, but it would be really better, good for our own good that we adopt to these particular practices. And we have to, again, there's a lot of investment, certainly a lot of investment, a lot of time consuming, but it is worth the effort to give more secure and quality software to our customers. This is what I have for today. Thanks.